Fourth graders, how's it going? It is Mr. Berglund here. So in class, you have just been working on these 5 practice essays. These are kind of examples of questions that you could potentially see on the test, but some also just a way for you to extend your understanding. So now I want to talk about and help kind of explain these questions, all right? So question number 1, explain how bowling relates to energy. Be sure to describe where kinetic energy, stored energy, and energy transfers takes place, and then draw a picture to support your explanation. So in order to do this, you're going to have to understand what those 3 terms are. So kinetic energy is energy that is in motion. When I am moving, when you're walking, when you're running, that's energy in motion. Stored energy is energy that is waiting to be used. Stored energy is in batteries. It is in food. It is in wood that is about to be burnt, okay? And then energy transfer is energy being transferred from one place to another. So basically, an object that has kinetic energy is moving, and when it hits or touches an object that is at rest, so this object is at rest right now, but as I hit it, my hand is hitting it, causing it to move. It wasn't moving before then, it was stable, but I'm transferring energy to it, causing it to move and fall over. Okay, so now let's think about how that relates to bowling. So I'm going to come down here to show you. So bowling, you have a bowling ball in your hand. Right now, we currently have kinetic energy in our body. As I am moving my arm back, I'm using kinetic energy to move my hand back, but at the same time, I'm storing energy in the ball, because the higher I bring this ball, this yarn ball back, the higher I go, the more energy I'm storing in the ball. Now, as I come down, I'm still using kinetic energy, but then I'm going to release the ball. As I release the ball, my hand, which had the kinetic energy, energy is transferred from my hand to the ball, causing it to move and roll down the lane. Now the bowling ball has kinetic energy because it is rolling. And remember, the pin is steady. So as the ball is rolling, this pin has stored energy in it. As it rolls, it hits, and the bowling ball transfers the energy from the ball to the bowling pin, giving it kinetic energy, and then it falls over. Again, so storing energy in my hand, but in the bowling ball, the higher I go, the more energy that's stored. As I bring my hand down, I am using kinetic energy to move my hand. But then as I release the bowling ball has now been given energy that was transferred from my hand to the bowling ball. It's rolling. It has kinetic energy. It hits the bowling pin, transferring energy from the bowling ball to the bowling pin, which causes it to knock down. Question number 2, draw a transverse wave and explain how it moves. Next, label the parts of the wave, describing what they are. You should have included what the medium, the crest, trough, wavelength, and amplitude are. Okay, so here we go. Transverse wave is a wave that moves perpendicular to the direction that it is moving. Basically, what I mean is you have to understand what perpendicular is. It's when 2 lines meet right here, and they form and create right angles. So the energy in the wave is moving up and down, while at the same time the wave is moving left to right or right to left. Okay? Now we got to talk about what are the parts of a transverse wave. Let's talk about the medium. The medium is this. I'm going to go a little thicker. The medium is this dotted line right here. The medium is a substance, which can be a solid, liquid, or gas, through which something travels through. In this instance, is a substance through which a wave travels through. Okay, the crest of the wave. The crest is the highest part of the wave. There is no point higher than the crest. Remember, you've all done this for your transverse wave project. I am just reviewing for you. The trough is the opposite of the crest. The trough is the lowest part of a wave. There are 2 troughs in this transverse wave. Talk about the wavelength. If this is a crest, that means the wavelength is the distance from one crest to another crest. Distance from one crest to another crest, that is the wavelength. I'll just do that right there. And that means the last one we have to talk about is the amplitude, which is demonstrated right here. The amplitude is the distance from the resting position or the medium to the crest or the highest part of the wave. All right? Remember, amplitude is the amount of energy in the wave. The more energy in a wave, the higher the amplitude will be. The less energy in a wave, the lower the amplitude will be. Okay? Draw a sound wave with a high volume and a low pitch, then draw a sound wave with a soft volume and a high pitch. Explain how the amplitude affects the volume as well as how the wavelength affects the frequency of the pitch. So again, in order to draw this, you're going to have to understand what affects the pitch and volume. All right, so let's see Sound wave with a high volume and a low pitch. All right, so high volume, low pitch. So look at high volume means that there's going to be a higher amplitude, right? Because the amplitude, it means the distance from the crest to the medium, or from the medium to the crest, either way. And it is the amount of energy that's in the wave. So the louder a volume is, the higher the amplitude will be. Okay, but let's see, we wanted a low pitch. So look at the lower the pitches, the longer the wavelengths will be. In this instance, in this model, there is a very long wavelength. So that is a low pitch. But if we looked at a high pitch, now we wanted a high pitch with a low volume. Look at, so we have a lower volume. The amplitude is much, much, much lower. The amplitude is much smaller, not as high. So the volume is going to be shorter or softer. But high pitch, remember, the pitch is related to the frequency and the wavelength. The higher the frequency is, the shorter the wavelengths. Look at one wavelength, two wavelengths, three, two. They're like little bunny hops, the wavelengths, compared to boom, 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 boom. So remember, the higher the pitches, the shorter the wavelengths will be, and the higher the frequency will be. The higher the volume, the higher the amplitude will be, because there's more energy in a wave. Let's see what else. What is the difference between a luminous object and a non-luminous object? Be sure to, what does that say, include examples of both objects. All right, so a luminous object is an example like a flashlight. A luminous object is able to create and emit, give off its own light. So we have a light bulb that is up above here. The light bulb is giving off its own light. A flashlight gives off its own light. The largest light source in the world is the sun. It gives off its own light. It creates its own light. But then you have an object like, let's hold up this box. This box is a non-luminous object because it is not creating its own light like the flashlight. It is reflecting light. So non-luminous objects, there are more non-luminous objects in the whole world than there are luminous objects. And so a non-luminous object basically reflects light. Light is bouncing off the object into our eyes, and that's how we're able to see it. Without a luminous object like this light, or this light that's coming through from the sun, we would not be able to see non-luminous objects. Okay, and the final question, what is refraction? And please explain why it occurs and provide examples of it. So I'm going to have to come here. I'm going to exit out of here 1 second. Okay, refraction. So here's a picture of refraction occurring. So you might be wondering, what is refraction? So refraction is the bending of a light. Light changes speed when it travels through a different material or medium. So look, we have, remember, medium is a substance through which something travels through. So light is traveling through two different mediums here. We have the air, which is above here, and it's traveling through water. When it travels through water, the light waves slow down, which makes the frequency and the light waves traveling through our eyes a little slower than it is up here. So basically, it looks like this popsicle stick is bending, but we actually know that it is a flat popsicle stick. It's just that due to refraction, it looks like it's bending because the light is traveling through two different mediums. We have air, or a gas, and a liquid. Okay, kiddos, so that was basically a brief review of your essay questions, practice essay questions, I should say. So review your science notes in preparation for your test. I believe in you. Good luck, and I will see you soon.